Okay, we will be hearing next from Stephanie Dudley. Stephanie is the Mission Integration and Utilization Manager for NASA's Gateway program, about how the Gateway Space Station builds on more than 20+ years of science and international partnership on the ISS and low Earth orbit to provide unique opportunities for science utilization in the deep space lunar environment. So please join me in welcoming Stephanie Dudley to the stage.
Hello. So my name is Stephanie Dudley. I am the Gateway Mission Integration and Utilization Manager for NASA's Gateway program. So as you can see, I don't work for ISS. I'm very happy to be back with my ISS family, but why am I here, right? I'm here to talk with you about Gateway, which is humanity's first space station around the moon, and how Gateway represents the future of utilization platforms in space. So this is Gateway. It is a critical element of the Artemis program. It's going to help us return humans to the moon and also help us chart a path for future human exploration of Mars. Gateway and ISS have a lot in common. It is not a stretch to say that Gateway is very much a part of the ISS legacy. Like ISS, Gateway is going to be the home for the crew members. They are going to eat, sleep, prepare for missions to the lunar surface, and it's also where they're going to do science. So we'll talk about that more in a moment. Like ISS, Gateway is building on the international partnerships and extending them from low Earth orbit into deep space. So we have CSA, ESA, and JAXA all contributing significant contributions to Gateway, and we may bring on additional collaborators in the future. So looking at the image here, we'll start on the right side. We have our power and propulsion element. It's going to be the strongest, most powerful solar electric propulsion spacecraft ever built. Maxar is building that for us. Next, to the left of PPE is the HALO module, Habitation and Logistics Outpost. Northrop Grumman is building that for NASA. It is the first habitable volume of Gateway. And these two elements will launch co-manifested and take about a year to spiral out into the Gateway orbit. Next is IHAB, the International Habitat. ESA is building IHAB with significant contributions from the Japanese Space Agency for systems like life support and batteries. On the far left of the stack is our logistics module. So it's going to bring all of the supplies that the crew needs and all of the payload research science that we're going to be executing during the mission. It's also going to take our trash away at the end of the mission. On the top of the Gateway, you see the reference human landing system. And then opposite that, the European refueling module. So ERM is going to allow us to refuel our xenon tanks so that we can survive up to a 15-year life in this Gateway orbit. And it's also going to give us some great windows. On the end of ERM is the Orion capsule. So Orion is going to be the crew transport vehicle. We'll launch, transit, and return the crew on Orion. Beside Orion, you see the reference airlock. This will be both a science and crew airlock for Gateway. And then on top of the HALO module, you see our Canadarm3, which will allow us to do robotics from Gateway. So how is Gateway different from ISS? So let's look at it. Gateway is about a fifth of the size by volume. So ISS took about 42 launches over 12 years to assemble. Gateway will take 4 launches over about 6 years. And whereas ISS has been continuously habitated for over 20 years and can accommodate 12 people, Gateway is designed for only 4 crew for up to 90 days. So most of the time it will be uncrewed. And so we are building autonomy into Gateway and anticipating that it could survive up to 3 years uncrewed. So now back to what ISS and Gateway have in common. And that's why I'm here, to talk about the payloads, the science. So we have 3 payloads that have been selected to fly on Gateway. They will launch with the initial Gateway elements. So first up is URSA, the European Radiation Sensors Array. So it'll launch external to the PPE. Second is the Hermes instrument. It's being built by the Goddard Space Flight Center, and will launch external to HALO. And then on the bottom, you see IDA, which is our internal dosimeter array that will, it's being built by ESA and has sensors from JAXA. So it will launch actually internal in the HALO payload bank. So all 3 of these instruments are going to be studying solar and cosmic radiation. So obviously this is a chief concern for deep space travel, and it will help the science community understand the space weather phenomenon. So our goal is to help keep both people and the hardware safe. So these 3 payloads, like I said, will launch with the initial Gateway capabilities, and we'll start collecting science almost immediately after launch. So when we think about Gateway as a utilization science platform, it all comes down to this, the science that we can perform in this very unique orbit. It is a unique position in deep space around the moon, and we want to take that into account when selecting science. This orbit takes about a week, and will bring Gateway within 1,500 kilometers of the moon at closest approach and 70,000 kilometers at the furthest approach. But this unique orbit allows many things that are unique, which we do not get in low Earth orbit. So this is a favorable vantage point for Earth, Sun, and deep space observations. This will allow us to make observations both of the deep space environment and be magnetically shielded depending on the phase around the moon's orbit. This also allows us direct comm with Earth and access to the lunar surface. Lots of opportunities in this unique orbit. So in summary, the science that we're looking for in Gateway requires this unique orbit that we've talked about around cislunar space, makes efficient use of our Gateway resources, provides science when the crew is not present, and provides opportunities for international collaboration. So if you would like more information, I would love to talk with you. You can connect with us and follow us on social media. Thank you.